Hi biology students, this is Mrs. Miller, and today we're going to be talking about our new unit, the chemistry of life. Today's section 1, which covers atoms, molecules, and compounds. One of the most important things we want you guys to be able to do today is to classify matter. Remember from physical science, matter is anything that has mass and takes up space. And when we talk about matter, we can classify it in one of two groups, either in pure substances or their mixtures. So what's the difference? Well, a pure substance is a sample of matter, either a single element, like gold, it's all right, gold in here, or a single compound, like water, H2O, that has a definite chemical and physical properties. So any sample of gold or any sample of water should have those same chemical and physical properties. A mixture, on the other hand, is a combination of two or more substances that are not, that's the big key here, they are not chemically combined. So a good example of this might be like Chex Mix. In Chex Mix, we can clearly see that within that bag we have all sorts of different types of food, but we can clearly tell that they are not chemically combined. In this particular unit, we're going to mainly focus on the pure substances. Before we can talk about pure substances, we need to bring it all the way back down to the atom. Remember, an atom is the smallest unit of an element that maintains the properties of that element. So down here I have a picture of an atom. We can see that middle part and then the outside where we have little electrons. So atoms are joined together to make all different kinds of matter. Atoms are also made up of subatomic particles. Remember, subatomic particles are like the protons, the neutrons, and the electrons. Let's start with looking at the term subatomic particle. So a subatomic, sub means below, atomic, so that means smaller parts that make up atoms. So there are 3 subatomic particles that we've studied, and you have all seen these in physical science before. We have our electrons, our protons, and our neutrons. So at the bottom here, we see 2 examples of atoms, and inside the middle, we're going to have our protons and our neutrons. Around the outsides, that's where our electrons are. This is a nice little table that organizes all 3 of our subatomic particles, our protons, our neutrons, and our electrons. Let's start with our proton. So the proton, a couple of things that you want to remember is we abbreviate the proton with a P+, and the reason why we do that is because a proton is positive. So if you keep that together, positive proton, that's why we have the plus sign. The protons are located within the nucleus. Remember, that's that central region right in the middle of an atom. And the mass is something that we say 1 AMU. And an AMU stands for an atomic mass unit. And that's just a way to express a really, really small value. Next up, we have the neutron. So with a neutron, neutrons have no charge and they're located in the nucleus. So if you think about all of those ends together, neutrons are neutral or have no charge and they are located in the nucleus. So when we write out their symbol, we have an N with a 0, and their mass is 1 AMU as well. Last but not least, we have the electron. Electrons have a negative charge, and we are going to abbreviate them with an E and a minus sign. Most of the time that's lowercase, but that's okay to do uppercase. Their charge is negative, so they're the opposite of a proton, and they're located in those orbitals. The last thing I want you to notice about this is the fact that the mass is 0. So we consider electrons to be so little that they have no mass at all. When we talk subatomic particles, we also are going to talk about a few terms. One of the terms that you guys are going to want to become familiar with is the atomic number. The atomic number is the number of protons that an atom has. So the protons tell us about the identity. So for example, the atomic number of hydrogen is 1 because in the nucleus of that hydrogen, it has 1 proton. The atomic number of oxygen is 8, so it has 8 protons. In this case with helium, helium has an atomic number of 2, therefore helium has 2 protons. So atomic number also tells us the number of electrons in a neutral atom. To be neutral, it means no charge. So if we looked at helium and it was neutral, we would say that it has 2 protons and it would also have 2 electrons. The mass number is the rounded atomic mass, which tells you the number of particles in the nucleus of an atom. So remember, the particles in the nucleus would be the protons and the neutrons. So this helps us to figure out the number of neutrons, which is always helpful. So we want to know how to find that. In order to do that, it's pretty simple. What we want to know is we want to figure out how many neutrons are in this oxygen atom. Okay, so we have an atomic mass. What we want to do is we want to round that to get the mass number. So I'm going to write down 16. And then you subtract the atomic number, which is listed up here, minus 8. And when I do that, I end up with 8 neutrons. So it's that simple to go and calculate your number of neutrons. Ions and isotopes should also be reviewed from last year. So ions result from having an uneven number of protons and electrons. What this means is that we have some sort of a charge. So that's where it is not neutral, is when we get this charge. Sometimes we're going to see that an atom loses electrons or has less electrons than protons, and it has a positive charge. We call this the cation. I like to think of it as cats have paws, so they're positive. Get it? Sometimes we also have atoms that have more electrons than protons, and these are negative charges. So that's called the anion. I like to think of this as a negative ion. If you can keep those two together, cations are positive, anions are a negative ion. So ions are because we're changing the number of electrons, but what happens if we change the number of neutrons? Well, that's where we get isotopes. All isotopes of an element have the same atomic number, meaning they have the same number of protons, but they have a different atomic mass because they have a different number of neutrons. So in this case, we have 2 versions of helium. In this case, we have 1 neutron, and in this case, we have 2. They're both helium, but we have an ion of helium right here that has 1 less neutron than normal. As we continue to talk about pure substances, the next thing that we should talk about are elements. Elements are pure substances that only contain one kind of matter or one kind of atom. They cannot be separated or broken down into simpler substances by chemical means. Each atom has its own unique set of physical and chemical properties and can be found on this periodic table. So you guys probably already know some of these elements like carbon, oxygen, helium, hydrogen. And each one of those that is listed in our periodic table, each has its own properties. And each is only made up of the same type of atoms. So gold is only made up of gold atoms, and so on. After we're able to find our elements on the periodic table, the next thing that we want to be able to do is locate their distinct chemical symbol. So examples of this would be C would be carbon, O would be oxygen, Mg would be magnesium, and so on. Each one of these separately represents a different element. However, sometimes we can put some of these elements together. and that's where we get molecules. So a molecule is the smallest unit of a substance that keeps all of the physical and chemical properties of that substance. Here's the important part. A molecule consists of two or more atoms that are chemically combined in a definite ratio. For example, we have O2. That's one oxygen connected to another oxygen. That's two or more atoms, so it's a molecule. We have H2O. We have two hydrogens, one oxygen. Because there's two or more atoms combined, that's a molecule. Or C6H12O6. Again, we have a lot of molecules, atoms, 24 atoms in fact, and that would tell us that we also have a molecule. One thing we see with students a lot is they get the difference between compounds and molecules incorrect. So pure substances that are not elements are going to fall in the category of compounds. A compound is composed of more than one kind of atom that are chemically combined. So for example, CO2. When we look at that, we have carbon and oxygen, more than one kind of atom. Therefore, this is a compound. Water, H2O. We saw that previously. Because it's made up of more than one kind of atom, it is also going to be a compound. So if I look at these two examples down here, I have O2. This has two or more atoms, so therefore it's a molecule. It is not a compound because it's only made out of one element. However, we have C6H12O6, which is glucose. We know it's a molecule because two or more atoms are coming together, but it's also a compound because it's two different elements that are coming together. So only a molecule because it's the same atoms. This one is a molecule and a compound because it's more than one kind of atom. So that's the really tricky part, but hopefully you'll be able to keep those two separated. Lastly, let's talk a little bit about mixtures. One thing that happens with students a lot is they get mixtures and compounds mixed up. But what we want to keep in our minds is that the properties of a mixture are dependent on the substance it contains. So a mixture's components can vary in proportions. That's why when we look at a bag of M&Ms, sometimes you get more red M&Ms than your friend does. And also, a compound has a definite composition. So when I compare these two pictures down here, compound every single time has a blue part and a red part. Every single time. Here, when we look at our mixture, we have some that are like that, but we also have these random triangles. We have this little shape. We have our little circles. So mixtures can have different amounts in them, and they're not chemically combined. Compounds are chemically combined. Let us know if you guys have any questions. Otherwise, have a great day.